Okay, welcome back to another Learning Lounge video. This one we're going to be going over the calculus on the IB Stat test or the SL Math AI test. So, what are we going to be covering? We're going to be going over the integration on it, derivation, and trapezoidal sum. Those are the three main calculus aspects on the test. There's also a lot of things from geometry or algebra 2 that come back, and these things called a Voronoi diagram, but those aren't really calculus based, so you're going to be learning those separately, and these are just the main points that I guess would be harder. Sorry, my dog is barking. So, the integration is really simple integration. It's just basically going to be the typical numbers, not any trig functions or anything, and you're going to be able to use a calculator for most of it. And so it's going to be, yes, so if we're doing it with a calculator, you go to y equals and you plug in your equation into y1, or I guess you can do it with any other y if you had things in there already, but y1 just makes it the easiest. And then that's going to be the exact equation that you're given. And then you would press exit, so you're back on the main calculator screen, and you're going to go to alpha F2, or where it says window. And then from there, you're going to press, it says int in it, so it's integration, or it's to just press number 4 if you get the hang of that. And then at that point, it's going to pop up on the screen, and there's going to be places to enter values, and you're going to put the endpoints of the integral it has if you need them. If it doesn't have endpoints, you wouldn't put those, and you would just do normal integration without. But I'm pretty sure on most of the stat test, it's going to be definite integrals. And then in the main parenthesis where you're putting in the equation, you're going to do alpha F4, where it says trace, and that's going to be able to let you plug in the thing you plugged into y. And you could just rewrite the whole equation there, but this saves a little bit of time if you have to do multiple steps with the same equation. And then you're going to press y1, which pops up that equation, and it'll give you your answer. And then, you have to plus x, where it would be the variable, because it's showing that you're integrating in terms of x. So it'll have d and then a blank at the end, and you're just going to press x on your calculator. And then if you wanted to do it by hand, because maybe the calculator's scary or something, or it would just be one that you can recognize as faster by hand and you don't want to go through all of these steps, you're just going to go with the formula of x to the nth power would go to x to the n plus 1 over n plus 1. So let's say you had x squared, that would become x cubed over 3, right? Things like that. That's just basic integration formula. So now derivation, which is the opposite of integration, you can also do with your calculator or by hand. And on the math test, it's going to typically be wanting the derivative at a certain point, not just a definite derivative or just a general derivative. So it's going to be giving you like a set number value that is the answer. So you can do this with your calculator by going and again plugging in your original equation into F1, and then into y1 in the y equals, and then you're going to go again to window, but this time instead of going to the integration button, you're going to be going to nderive, or it's the third one right above the integral, and this one's going to get you into the normal integration formula. And you're going to have to plug in x to the first opening, so it's going to be like d over d blank. You're going to be putting in x because you're showing that you're doing it in terms of x, because that's what your equation's written in. And then in the main parenthesis, so where it's asking like what you're deriving, you're going to press the alpha 4, which lets you plug in y1. Again, you could do this with just punching in the equation, but it's just easier if you have multiple steps to do to have it in Y1, and then you can just go and plug in. And then this one, in the last box, it's going to say x when x equals blank, and you're going to plug in the number that it tells you x is going to be equal to, and then that's going to just give you the derivative. If you wanted to do this by hand, again, because you don't like the calculator that much or you just think it's easier, then you're going to just use the formula that x to the nth power changes to n times x to the n minus 1. So if we had x squared, right, the integral of that we said would be x cubed over 3. The derivative of that would be 2x, right, because you have n, which is the 2, comes in the front. So you have 2x, and then 2 minus 1 is 1, so it's 2x to the first power, which is just, we don't write that. So, yeah, and then last we have the trapezoidal sum, which is a form of integration, but it's one of them where it's finding integration, like the area under a curve of something, which is not going to be like a calculator plugin. This is just, you're going to have to memorize the formula, and you're going to, so you're finding the area, and you're going to be given a table, and it's going to say, like, with this many steps or something, this many brackets, so, or I guess trapezoids, because that's what you're making, it's going to give you a certain amount you have to do, and you're just going to be using these steps. So you're using the formula of the sum of 1/2 of the change in x times y1 plus y2. Because if you think about a normal trapezoid, how would you find that area? You have your two sides that you're adding together, the long sides, and then the two diagonals, you multiply by half of them, right? The change in x, I guess. And basically, you're just making a bunch of sideways trapezoids under your curve, and that's going to be giving you an area. And then, so you plug in the appropriate values. So if you have your table, and let's say it's increasing by 2 on every interval, then your delta x would always be 2, and then your y1 and 2 would be whatever the two numbers underneath the values that you're using are. So it's easiest to, if you have your table, just draw a little like connecting lines between the consecutive segments so you know what numbers you're using. That makes it easier to plug in. And then, so yeah, here's our example. So we have f and then f of x. And so notice, first of all, how the delta x isn't always constant. So first we have a change of 2, and then 1, and then 3. So you want to pay attention to that. And so in this one, what would we do? We would plug in the formula. So you'd have 1/2 and then a bracket. And then we have our first delta x, which is 2, times 15 plus 30, because that's what's underneath those values. And then we'd add it to our next delta x, 1, times 30 plus 25, because those are our two y values. And then our last one, 3 times 25 plus 50. And then we would get that equation, and you're just going to plug that into your calculator, making sure that you keep mind of all the parentheses and such, and you would get that this volume, this area, is 185.